Here is another problem on a force system where the force is described by an equation. So you have your two supports, it's A and B, and your force is given by W is equal to minus 2x squared plus 4x plus 16 Newton per meter. So the total load will be the area under this curve, and that load will be acting at the centroid of this area. So if you consider a strip here, let's say we can consider a strip, a small strip here, with okay, and let's call this distance dx, and the distance to dx from A is x, and you know the height of this strip is the equivalent force at this point, and now we are assuming it as a rectangle. So the area of the strip is equal to dA is equal to W into dx, that is the height into the width of this strip here. So we need to integrate this differential area over a length of 4 meter, and you know the W is given by this equation. So you have integral dA over 0 to 4 is equal to integral 0 to 4 W dx, and that is equal to integral 0 to 4 minus 2x squared plus 4x plus 16 dx, because that's the value of W, and that will give you, differentiate all these, integrate all these, so you will have minus 2 x cube by 3 within limits 0 to 4 plus 4 x squared by 2 within limit 0 to 4 plus 16x 0 to 4. And that is minus 2 into 4 cube divided by 3 plus 4 into 4 squared divided by 2 plus 16 into 4, and that will give you, I'm just using my calculator here, 4 cube divided by 3 into minus 2 plus 4 cube by 2 plus 16 into 4, that is 53.33 Newton. So that's the area under this curve. So that will be the total force of this force system. Now you need to calculate the centroid of this area, and we know the centroid of an area is, we only need to know the x distance. So x bar is equal to, the centroid is equal to integral x dA over integral dA, and we know integral dA is 53.33, so that will give you, and we know the dA is W dx, so we have integral x dA is equal to integral x into W dx over 53.33, and that's equal to integral x into minus 2x squared plus 4x plus 16 dx over 53.33, and that's equal to integral, the integral is 0 to 4. Minus 2x cube plus 4x squared plus 16x dx over 53.33, and that is minus 2 x raised to 4 by 4 plus 4 x cubed by 3 plus 16 x squared by 2 within limits 0 to 4 over 53.33, and after calculation you will have minus 2 4 raised to 4 by 4 plus 4 into 4 raised to 3 by 3 plus 16 into 4 squared by 2 over 53.33, and that's equal to, again I'm just using my calculator here, that is 4 cube by 4, 16 into minus 2 minus 32 plus 4 raised to 4 by 3, 3.33 plus 16 into 16 by 2 divided by 53.33. That will give you 1.6, that is equal to 1.6. So that's the distance of the centroid from the left hand side, because we considered the distance from here, so you have that from here. So in effect your load system will change like this, that is your total load is 53.33 and that is acting at 1.6 meter from point A. So now you can calculate the reactions at A and B. So you just need to apply the conditions of equilibrium here in order to calculate RA and RB. So taking moment about A, you have 53.33 acting downwards at 1.6 meter, so creating a clockwise moment, therefore negative, and RB acting at 4 meter upwards, creating a counterclockwise moment, therefore positive. So you have 4RB is equal to 53.33 into 1.6, or RB is equal to 53.33 into 1.6 divided by 4, that is 21.332, and we know RA plus RB is equal to 53.33, therefore RA is equal to 53.33 minus RB, and that's equal to 53.33 minus 21.33, and that will be 31.998. So you have RA is equal to 31.998 and RB is equal to 21.332 Newton. If you have any confusion in calculating the centroid or center of gravity of an area shown here, please go through the video where we discussed centroid and center of gravity. So the answer here is your total force 53.33 acting at 1.6 meter as a point load, and your reactions are Ra 31.99, Rb 21.33.